Click the bell icon to get latest videos from Ekeeda.
Hello friends, here in this video we will see the another problem on Clapeyron's 3-moment theorem. Today we will see a continuous beam with sinking of supports. That is also an important type, should come in exam 10 to 15 marks or 20 marks, a sinking of support. So let's see in details what is sinking of support is going to work, and let's do the E and I also. So let's see in details. Now see friends, this is a question given to us, a continuous beam with sinking of support. Question number 4, analyze the beam by using 3-moment theorem or Clapeyron's theorem. Support B, see this support B sinks by 5 mm. Support B sinks by 5 mm. I will be 9300 centimeter raised to 4. E will be 2.1 into 10 raised to 5 Newton per mm square. Okay, so now this is a diagram given to us. So let's start with the solution. What's our first step? First step will be free bending moment. Our first step will be free bending moment. So let's start. For span AB, bending moment at E will be, see, for span AB, bending moment at E. For span BC, bending moment at F. For span CD, bending moment at G. So here formula will be, C. Forget to write one thing. This distance will be 2 meter and this distance will be 3 meter. Means it's a eccentricity. So A and B will formula will come. It's not in center. So formula will be WAB by L. W will be 80, A will be 2, B will be 4 upon L will be 6. Answer will be 106.67 kilonewton meter. After that, for span BC, bending moment at F is equal to, the formula of in C at BC part, this is there is a UDL. So formula will become WL square upon 8. W will be 20, L will be 5 square upon 8. The answer will come 62.5 kilonewton meter. After that, for span CD, bending moment at G will be WAB by L is equal to 60 into 3 into 2 upon 5 is equal to 72 kilonewton meter. Okay, now after that, our next step will be, we have to draw the bending moment diagram and find the area of that diagram. So first of all, in this case, what we have to do, see our support B sinks by 5 mm. Means we have to convert in meter. So it will come 0.005 meter. It means minus 0.05 meter downward, because see, this is a beam, the beam is sinking downwards, that's why we are using minus sign. Okay, 0.005 meter. Now here E value will be 2.1 into 10 raised to 5 Newton per mm square, or I value will be 9300 centimeter raised to 4. While into both of them we have to convert into kilonewton per meter square. Kilonewton per meter, because our loads are in kilonewton, our distance are in meter. That's why we have to convert to kilonewton meter. So how will you convert? Now see, this is 2.1 into 10 raised to 5. This is Newton. Okay, raised to 5 Newton per mm we have to convert into meter. So it will be 10 raised to minus 3 the whole square meter square. Okay, here will come 2.1 into 10 raised to 5 into, this will get opposite 10 raised to 6 Newton per meter square. See, this will convert into Newton per meter square. Let's move on to I. 9300 into 10 raised to minus 2 raised to 4 meter raised to 4. Now we have to convert centimeter into meter. So 10 raised to minus 2 raised to 4 meter raised to 4. So it will come 93 00 into 10 raised to minus 8 meter raised to 4. Now we have to into both of them. Hence we have to into like this. E into I is equal to 2.1 into 10 raised to 5 into 10 raised to 6 into 9300 into 10 raised to minus 8. While into this, see, this value will be Newton per meter square. This will in mm raised to 4. Okay, so it will come 19530 into 10 raised to 3 Newton per meter square. See, meter square and meter raised to 4, 2 will get cancelled, so it will remaining meter square. After that we have to convert into kilonewton. So 19530 kilonewton per meter square. We have done with this part. Okay, now this is a conversion of E and I am explaining. Okay, now let's start the problem now. Second step will be free bending moment. So right over here, second step will be free bending moment diagram. Now draw the diagram. So this is A, B, C and D. So friends, now what we are doing, we have drawn the bending moment diagram. Now we will find the area of all these three parts and XL and XR. As you remember, XL and XR is nothing but is the center of CG of this part and CG of this part and CG of this part. Our left XL means from left side, XR means from right side. Okay, so here area will be half into base into height, so it will come half into 6 into 106.67, so it will come 320.01. okay, here XL formula will be A plus L upon 3. Here A will be, now see the diagram. This is your A part, this is B part, this is A part, this is B part. A will be 2 plus L will be 6 upon 3 is equal to 2.67. okay, 2.67. After that XR will be B plus L upon 3. B will be 4. 4 plus 6 upon 3 is equal to 3.33. To add this we will get the 6. Okay, now let's move on to here. Area will be 2 by 3 B into H. 2 by 3 B will be 5, H will be 62.5. Here value will come 208.833. okay, this is a value. Here XL will be at center, means 2.5 meter. XR will be at center, 2.5 meter. okay, now let's move on to here. Here also area will be half into base into height. Half into base will be 5, height will be 72, that will get 180. And XL will be A plus L upon 3. XR will be B plus L upon 3. Here A will be 2. 2 plus L will be 5 upon 3 is equal to 2.33. Here B will be 3 plus 5 upon 3 is equal to 2.67. Here we have done with this part. We have find all the areas. So please remember, in exam no need to write A1, A2 and A3. I am explaining again and again friends. Always write only A, XL, B, A. When we are solving A, B, C, this is your L1, this is your L2. When we are solving B, C, D, this is your L1 and this is your L2. What is our third step? Our third step will be nothing but apply three moment theorem. Now we have to apply three moment theorem. So for where we apply three moment theorem, see first, as the name indicates, 3 A, B, C, then B, C, D. Okay, so for A, B, C, to see this, write the general equation of this will be MA L1 plus 2MB L1 plus L2. Since there is no here, no moment of inertia will be there, I and 2i, that's why I am not writing upon EI. If there, you have to write upon EI plus this MC L2 plus 6a1 x1 upon L1 plus 6a2 x2 upon L2. Okay, now see, in exam you have to remember one thing. See, support B sinks by 5 mm means 0.005 meter. Now see here also a support B is there, means support B is sinking, so you have to add in equation is this plus 6e1 I1 delta 1 upon L1 plus 6 E2 I2 delta 2 upon L2 is equal to 0. These things you have to add when this, instead of when this thing you have to add when this 3 A, B, C either one is sinking. At that time only you have to add this. If A is not sinking, B is also not sinking, C is also not sinking, so no need to add this. If in this 3, if anyone is sinking of support, so you have to add this formula. Okay, please listen carefully. If 3 of them are not sinking, instead of 3 of 1 are not sinking, do not use this formula, do not use this part. Okay, if 3 of them 1 is sinking, we have to use this formula. Okay, now we have to find delta 1 and delta 2. I am just explaining with a small and very simple concept to find delta and delta 2 will be this. See delta 1, how will you find? See, this is a center, so you will write YB minus YA. Reflection at B means reflection at A. After that, to find delta 2, YB minus YC. What you have to do? BA then BC, BA then BC. B is in center, YB first, YB first, YA, YC minus. Okay, now we have to apply. C. Which support is sinking? Support B is sinking point by minus 0.005 mm, then minus support A will be sinking, no sinking, that's why it will get 0. So your delta 1 will be minus 0.005. Okay, now delta 2 minus 0.005 minus 0, delta 2 will be minus 0.005. Always remember, not always delta will be minus 0.005. It will get you at next one. Okay, always remember delta 1 and delta 2 always not will be minus sign. When you are solving for BCD, then at that time you will get. Okay, now after that apply. Now we have to apply. So here we have to apply the formula. So what will come? See here MA is 0 because it is extreme corner, so it will directly come 0 over here. 0 plus 2 MB 6 plus 5. I am explaining again and again. Always remember, we are doing A, B, C. This is your A1, this is A2, this is L1, this is L2, this is L1, this is L2. Okay, so 6 plus 5, then plus MC into 5 because it's not a extreme corner, plus 6 into 320 into 0.1 into 2.67 upon 6 plus 6 into 08.33 into 2.5 upon 5. Now see friends, where is 2.67 is coming? See, at this one you are seeing A, B and C. We have, why we are writing 2.6 or not writing 3.33? Because since we are considering this part only, you have to write x distance from the left side, from here, and you have right side from here, because we have to take the extreme corners. See, this distance is nothing but XL, means left side, so that's why we are taking 2.67, and here we are taking XR 2.5. when we are taking BCD, at that time this distance we are taking XL, and here we are taking SR 2.67. okay, here we are taking 2.67. please remember, if we are assuming A, B and C, we have to take the x distance from the this side, we have to take the x distance from the this side. Okay, that's why I am taking this value 2.67. after that plus 6 into 19530 is nothing but EI or into minus 0.005 upon 6 plus 6 into 19530 into minus 0.005 upon 5 is equal to 0. Okay, while solving this you get 22 MB plus 5 MC 1479.42 minus 214.83 is equal to 0. Okay, so here will you come 22 MB plus 5 MC is equal to minus 1264.59. This is nothing but equation number 1. Underline this equation number 1. Okay, for B, C, D. Now see, since it is a 3 moment theorem, we have done A, B, C. Now we have taken B, C and D. Okay, now at the time of B, C, D, this will your A1 and this is your A2. This is your L1 and this one is your L2. So first write the equation to see here. MB L1 plus 2MC L1 plus L2 plus MD L2 plus 6A1 X1 upon L1 plus 6A2 X2 upon L2. Now here we have to add or not, since which support is sinking, B support is there. So here also we have to add plus 6 delta 1 E1 I1 upon L1 plus 6 delta 2 E2 I2 upon L2, okay, is equal to 0. Now I am explaining how will you find over here also. Delta 1 will be YC minus YB, delta 2 will be YC minus YD. Now see, YC is sinking, not sinking, that's why 0. So that minus YB is sinking, minus 0.005. Now see here, delta 1 will be 0.005 friends. See the changes of delta 1 over here. Always remember, no need to write directly minus 0.05 at all the time, because see here delta 1 value will be 0.05. Why it will get? YC is not sinking, that's why 0. This minus sign and minus will get plus over here. Okay, so here delta 1 will be 0.005. Okay, now delta 2 will be YC is sinking, not sinking. YD is also not sinking, both are 0. Delta 2 will be comes over here 0. Okay, so remember carefully, the delta value is not always whatever they given in the question. We have to find the delta's value to see the diagram. See this A, C and B and C and D. Okay, now after that put all the values. 5 MB plus 2 MC, 5 plus 5 plus this is extreme corner, that's why 0 plus 6 into 208.33 into 2.5 upon 5 plus 6 into 180 into 2.67 upon 5 plus 6 into 0.005 into 19530 upon 5 plus 0 equal to 0. Okay, now see friends, where this distance is coming 2.67 and 2.5. Now see the diagram, we are using B, C and D. Now here we are taken this distance of this parabola and this distance of the triangle, means this is your XL and here we are taking this value 2.67 from XR 2.67. Okay, please remember we have to take this distance from this side and this distance from this side. Okay, now after that by solving you will get 5 MB plus 20 MC plus 624.99 plus 576.72 plus 117.18 is equal to 0. This is 0.72 friends. Okay, here will come 5 MB plus 20 MC is equal to minus 131.8.89. This is nothing but equation number 2. Now see friends, we have done the equation number 2. Now what we have to do? Now always please listen carefully and remember only one thing, this x value, we are taking this corner and this corner. This is the funda of this chapter. It's quite simple chapter. In exam compulsory question for 10 to 15 marks is coming. Okay, so now solving 1 and 2, we get MB is equal to minus 45 kilonewton meter and MC will be minus 54.68 kilonewton meter. This is our final beam moments of MB and MC while using Clapeyron's 3-moment theorem. Okay. Now after that, our next step will be find support reactions. Support reaction. To find support reaction calculation, first draw the diagram once again at different cut like parts. I am explaining you. See. Now see friend, this is a diagram given to us. Now what you have to do, see, we have find this as a minus, that's why hogging 45. This is also we have find, this is also a minus, this is also 54. So we will draw like this. See, from section this side this will get hog, from section this side this will also get hog. That's why I am writing like this. Now find RA and RB by using different steps. So let's start. Taking moment at A equal to 0, clockwise positive. So what's the value will come? See, first will come 80 into, see, this distance is 2 meter and this is 4 meter. 80 into 2 clockwise. After that minus RB into 6. After that this is clockwise. So plus 45 equal to 0. Here RB will come. Okay. After that summation Fy equal to 0, upward positive. Here we get this value will be 34.17. So Ra minus 80 plus 34.17 equal to 0. So your Ra will be 45.83 kilonewton. Now here also taking moment at B is equal to 0, clockwise positive. So first is 20 is coming, the 20 into 5 into 5 by 2 positive, 20 into 5 into 5 by 2. After that minus RC into 5. After that, see, this is anti-clockwise, so minus 45 plus this is clockwise 54 is equal to 0. So RC will be 51.8 kilonewton. After that summation Fy equal to 0, upward positive. So RB minus 20 into 5 plus 51.8. Your RB will be 48.2 kilonewton. Okay, now here taking moment at C equal to 0. See friends, it's quite very simple. I am just explaining again and again in all the problems because still here you have to do the during exam. See, what's the come in the picture will be 60 into 2 minus RD into 5 is equal to 0. Here RD will come. Sorry friends, sorry. Now we have forgot one thing. 60 into 2 minus RD into 5. Now see here this is also coming anti-clockwise, so minus 54 is equal to 0. So here RD will be 13.2 kilonewton. Okay, here summation Fy equal to 0, upward positive. RC minus 60 plus 13.2 is equal to 0. RC will be 46.8 kilonewton. Okay friends, we have done the support reaction calculation. Now what we have to do, reaction at A will be this, reaction at B add both of them, reaction at C add both of them, reaction at D is 13.2. Now after that draw one diagram and once again and draw the SFD and BMD. I am explaining only bending moment. SFD we have to draw, so take the problem number 1 in previous video. I have already done how to draw the SFD in this chapter. Okay, reaction at A is equal to 45.83 kilonewton. reaction at B is equal to 34.17 plus 48.2 is equal to 82.37 kilonewton. See this one, 34.14 into 48.2, 34.17 for 48.2. After that, reaction at C will be 51.8 plus 46.8. 51.8 plus 46.8, 98.6 kilonewton. Reaction at D will be 13.2 kilonewton. We have done all these things, A, B, C and D. After that, our fifth step will be draw bending moment diagram. So for bending moment diagram, first of all draw the diagram. This not look like a parabola, but it's a parabola. You can draw neat, okay? It's not like a parabola, but it's a parabola. This value will be 106.67. This value will be 62.5. This value will be 72. Now we have to find, here we have to put the beam moments A, B, C and D. So it will come 6 meter, here will come 5 meter, here will come 5 meter. This is your bending moment diagram. Now let's start with the beam moment. Here A will be 0. Here B will be something 45. C will be something 54. So 54 becomes over here. Now draw all those things. Now this is your, this value will be 45 kilonewton meter. This value will be 54 kilonewton meter. Here we have done this problem. I am just remind you what we are doing now. See, I am just remind you once again. See friends, now we have done with these problems. I am just remind you, we see this in here, we have to remember a sinking and the EI value is there, okay? After that, what we start the free bending moment diagram. Since support be settled down by 5 mm, so we have to 0.005 meter. Conversion of E or I will be there. Free bending moment diagram, A, don't write A1, A2, A3, always remember friends. After that, apply 3 moment theorem, and to find the delta 1, delta 2, I am explain. After that, find for BCD, then solving 1 and 2, we get this value. After that, find support reaction calculation. After that, draw the bending moment diagram, or you have to draw the shear force diagram also. Please refer the question number 1. There I have drawn how to draw the shear force diagrams. Here I am explaining now also a shear force diagram is get quite complicated, some and too lengthy for them. Okay, that's why I am not explaining over here. Now we have done with these problems. I hope you understands my all videos. Share with your friends, and yes, don't forget to subscribe the Ekeeda channel. Thank you.